biggest fear with LLMs isn't what they can do, but what they might do when we least expect it. So what can we do as developers to systematically test these algorithms? In this video, I'll show you the frameworks that are used by some of the leading companies in the world to test their LLMs before they go into production. Hey there, my name's Arun and I have over a decade of experience in building full-stack applications and production-grade AI. And today I'm going to be showing you the Inspect AI evaluation framework for LLMs. So to run this code yourself, we're going to be using three main components. We're going to be using Inspect AI as our evaluations framework. We're going to be using OpenAI as the LLM that we're going to test, and we're going to be running this all in Python. So the first step is just setting up your environment. I've already created my virtual environment, so I'm not going to go through this process of setting this up, but it's pretty standard, and you can follow the instructions in the repository to complete this yourself. And as usual, you'll just need to install the requirements, which are all given to you within the repository. And then if you want to go ahead straight away and actually just run this straight off the bat, you can literally just run these commands here and it will run the evaluation tasks for you. But what I'm going to do is I'm going to walk you through how to actually set this up for yourself and to go into a little bit more detail about what's going on. So firstly, just to talk about the actual structure of the directory. So this logs folder will be automatically generated when you run the evaluation tasks. So this will essentially store the logs of the evaluation runs, and then we can actually visualize and look through and explore these logs as well. This tasks folder here contains a whole series of different evaluations that you can run. I've set these up for you so you can run all of these straight away on your computer. Throughout this tutorial, we're going to be going through three of these tasks, and I'll show you what it looks like when you run these tasks as well. They range from all different kinds of things, from just a hello world kind of like task, mathematics challenges, security, protocols, and even the use of tools as well. And to be honest, that's it. It's pretty simple. So now I want to talk a little bit more about Inspect AI. And to do this, I'm going to open up the documentation site. So here we are at the documentation. Inspect AI is an open source framework for large language model evaluations. And it's a framework that was created by the UK AI Security Institute. From experience and from working in the industry, I know that this framework is used to benchmark all kinds of different statistics against the leading LLM providers. And companies even exist to actually just simply report on the performance and the benchmarking of LLMs before they actually go out into production. Now, there are vast capabilities within this Inspect framework, but we'll only be covering a few of them today. But you can evaluate LLMs in terms of coding, agentic tasks, reasoning, knowledge, behavior, and multimodal understanding. And this documentation site contains everything that you need to get started, including instructions on how to install the package and even some quick start tutorials as well. There are three things that I'd like to dive into specifically around Inspect AI. The core of the Inspect framework is an evaluation, and an evaluation has three main components. Firstly, a dataset. Now, datasets contain a series of labeled examples. And this is typically just a table with an input and a target. The target could be a discrete value, or it could be guidance on how to actually get to the value. The second is a solver. Now, solvers are chained together to evaluate the input in order to get the final result. The most simple solver, which is the generate method, literally just takes the input, runs it through the LLM, and then evaluates the output against the target. Other solvers might do prompt engineering, self-critique, multi-turn dialogue, or even provide an agentic framework. And then the last component, the third component, is a scorer. And a scorer evaluates the final output of the solver. They could use text comparison, model grading, or some kind of custom scoring as well. So I've been talking about these evaluations, but why are they so important? Well, in the software world, you wouldn't release a system into production without testing it first. And we have all different ways of testing a system. You have user acceptance testing, you have unit tests, integration tests, end-to-end tests. And in the traditional world of software engineering, software would not be released into production until it passes all those tests. Now, this is very easy for things that can be discretely tested. But for an LLM, which is highly probabilistic and a generative model, and very qualitative as well, how do you test these models? Well, this is where evaluations, or evals for short, come in. It allows you to benchmark LLMs. And as you dive deeper, it allows you to do all different kinds of advanced stuff as well, such as being able to test any malicious intent that an LLM may have. And a big topic in the AI world is jailbreaking. So does this model have the capability to be jailbroken? And if so, how? So if you are interested in launching production grade LLMs, using an evaluation framework like this is really interesting to look into. So now jumping back to the code, once you've set up your environment and you've installed all the requirements, it's pretty simple to get started, and I'm essentially just going to show you how this runs. So I'm going to run you through some examples. We've got a hello world example, we've got a theory of mind example, and we've got a mathematical problem example as well. Now the key is that we're actually going to be testing an LLM for this, and as you can see I've specified the model that I want to test. So we are going to have to give a OpenAI API key for this. You can just run it and export it into the terminal so that it then knows which API key to use. But to get started, let's run the hello world example, and actually let's open up this code so I can just tell you a little bit more about what's going on. So to define a task within an evaluation, you use this task decorator above a function, and you can name the function however you want. Then, once again, within the Inspect AI package, it comes with everything that you need. You have data sets, you have scorers, and you have solvers. And, of course, you have the task class as well. So to register and run this task, this is as simple as it needs to be. We instantiate the task class, we provide the data set. In this example, we're just providing a text input, which is just reply with the word hello world. And the target that we're aiming for is the word or the string hello world. The solver that we're going to use is just the basic generate solver, because we don't need to do any complicated sort of like multi-turn critique or anything like that. We're literally just going to take the input, pass it through the LLM, and we want to try and evaluate it against this output. And the scorer that we're going to use is an exact scorer. So it's going to give us a score based on whether the output matches the target exactly. So to run this, let me come back to my README. I'm going to copy this command, and I'm going to run this in the terminal. So you get this nice interface whilst it's running, which gives you an understanding of progress, current performance, all that sort of stuff. But then it comes back with a very concise report as well. Now in this example, obviously this is the simplest example, so it didn't take very long. It gives us a score, standard deviation error, all that sort of stuff. But then it gives us a log file that it's output to as well. So if I come over to the logs, I'll now notice that there is now a log file here. I'll come back to this afterwards because I'm going to run a few more evals first before we actually start to view these logs. So the second example is the theory of mind. So if I open up this code, it should look very similar once again. But this time we're actually using an example dataset from Inspect AI. So this is the theory of mind dataset. We're going to be using a chain of solvers. So we're using chain of thought, we're going to be generating the output, and then we're going to use a self-critique technique as well. And then the scorer is going to be model of fact rather than the exact scorer. Now if I come over to the documentation very quickly, just to elaborate a little bit on what this dataset is. So the dataset is the Sally-Ann test, which basically assesses the ability of a person to infer false beliefs in others. So this is what the dataset looks like. You've got a series of inputs and you've got a series of targets. An input could be something like this. Jackson entered the hall, Chloe entered the hall, the boots is in the bathtub, Jackson exited the hall, blah, 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 blah. And then basically there's a question at the end. So where was the boots at the beginning? So you have some sort of question, some sort of problem, and then you have an answer which is essentially, the correct answer. So we're basically asking the LLM to solve this problem, to answer this question. So let's come back to Visual Studio Code, and now let's run this eval. Now this time, rather than just passing in a single test, there's going to be quite a lot of data in this sample data set. So you'll see that this runs for quite a while longer. Actually, at the end, you can see the progress. So there's actually 100 different observations that it's going to be testing. It keeps a running count of the accuracy as well, which is quite interesting. But I'm just going to let this run, and then I'll look at the report afterwards. Okay, so that's finished running now. Once again, it gives us a report in terms of the amount of time that it's taken to run, number of tokens that was used, the overall accuracy, standard deviation error, all that sort of stuff. And once again, it's outputted a log file, which we'll look at in just a moment. Before we do that, let me just run the last eval, which this time it's to do with a mathematical data set. So if I come back to the Inspect AI page, let me come over to the tutorial site. So this is the dataset that we're going to use. It's the Grade School Math 8K dataset. It's a dataset of 8,500 high-quality, linguistically diverse grade school math word problems. The dataset was created to support the task of question answering on basic mathematical problems that require multi-step reasoning. So here's some examples of some of the questions and answers within the dataset. So if I come back over to here and I open up the code, you can see that this is a little bit more complicated. We have some helper functions to sort of like support the overall task. And we're actually using a technique called few shot sampling here as well. So essentially we're going to be giving the prompt examples of answers in the past that may or may not have performed well, or example of good answers or bad answers. That's an example of few shot. And then as you can see, we provide a template for the overall prompt here as well. Then if I come down to the main task, you can see that we're going to be using 10 few shot examples. And you can see if few shot does exist, we're basically going to sample 10 examples from the GSM 8K dataset. This dataset, as you might see from this function here, is actually coming from Hugging Face. And then we're inserting these into the system message. And in this example, we're going to be using a match scorer, which is basically just matching whether or not the numeric answer is correct or not. So let's run this eval and let's see what we get. Now for this example, there are 8,500 data points in the dataset, and we don't want to run it for all of those examples. So what we're going to do is we're just going to limit it to 50, and let's run this. Okay, great, that's done. So once again, we get the report and we get the eval file as well for the logs. So now this is where the magic happens. So we've got our log files within the log directory. We've got 3 different log files. Now if we run inspect view, it'll open up a web application. It'll run it on localhost. So if I open this up in the browser, it'll give me a whole dashboard to now inspect and explore the logs of this evaluation run. So let's look at Hello World first. Now there's a whole bunch of information here. I'm not going to go through everything. I'm just essentially going to go through some of the most interesting or most important parts. So at the top, you get some metadata around the evaluation, the model. You even get some JSON that basically provides you with more metadata around the eval run. And then within the middle section here, you get some more information about the transcript that the actual process of the LLM went through, or the transcript that was executed throughout the inspect AI evaluation. So you can see it was initiated, then a solver was called, then a scorer was called, and then it gives you the information about which scorer it was used against. You can also look at the messages here as well. So the messages that go between the user and the assistant within the LLM conversation flow. Of course, you can inspect the scoring in this example because it is very simple. There's not really much going on here. It essentially just says, yes, you got it correct, which is fine. You get some metadata around the input tokens and the output tokens. And once again, you get some JSON just to sort of like summarize all this information as well. So this example doesn't really tell us too much because it is very simple. But if I go to the theory of mind, this is where it gets really interesting because now we can actually dive into specific examples within the data set. So let's choose one that's correct. Let's take this one. So sample number 18. If I click on this, I can now see the entire prompt that was generated by the solver and actually all of the chain of thought, essentially, all of the intermediate output that the LLM was going through in order to come to its answer. And obviously the output depends on which solver was used. So obviously we used the generate solver. So this was the output of the initial generate LLM request. And then after this caused the state to be updated. But then following this, it then went through the self-critique solver. So now, given the answer that you've just provided, I want you to critique this and I want you to improve it, essentially. So if I scroll down a little bit more here, yeah, you can see it's asking for critique, and the assistant essentially says, after its critical assessment, it says the original answer is fully correct, and therefore it's not going to go through another loop of generating an answer. So this is really interesting in terms of traceability, and in order to get a little bit deeper and a little bit more understanding about how an LLM actually works, and to get into the guts of what it's actually doing under the hood. And then once again, we can dive into a little bit more about how it's actually scored as well. So if we come over to the scoring, with this particular scorer, which was the model graded fact scorer, it's more of a qualitative scorer. So we give our answer, and then as you can see, it provides a whole qualitative sort of like reasoning and thought process as to whether or not our answer is correct. And then ultimately, I think it basically tells us that our answer is incorrect, which is fine. And then it even provides an explanation as to why this answer is incorrect. So if I come back to let's come out of this one and let's go back to some other examples. Okay, let's choose one where we did get it correct. So let's choose this one here. Here we go to the scoring. You can see that the answer is box. That is the answer that we gave, or that is the target answer that we were looking for. And then once again, you can dive into the explanation as to why this is correct as well. So this is super interesting. Now, of course, all of this does cost money to run these evaluations against a publicly available OpenAI model, because we are using an API key. But there's no reason why you couldn't run this against your own locally hosted LLMs as well, or privately hosted LLMs. Now, finally, let's go to the mathematical evaluation run that we did. So the GSM 8K. And this one actually did pretty well. It had an accuracy of around 94%, which is really good. So let's have a look at this first one here. I have 10 litres of orange drink that are 2/3 water, and I wish to add to it 15 litres of pineapple drink that is 3/5 water, but as I pour it, I spill 1 litre of that orange drink. How much water is in the remaining 24 litres? The correct answer was 15, and the answer that it gave was 15. So that's perfect. And you can see it's using the match scorer, so it got it exactly correct, as expected. So as I said, there's tons more that you can dive into in this Inspect dashboard, but really this is just to give you an overview and to give you a view under the hood about what's actually going on with an LLM in the background, and how you can start to interrogate LLMs and evaluate them for production use cases. So this is an introduction into what evaluations are and how you can start to run these evals against LLMs, as well as how to dive into the reports and to really interrogate what's happening under the hood. Why not try this out on your own LLM pipelines and let me know how you get on? If this helped you, don't forget to like, subscribe, and drop me a comment as well. Let me know if you're going to be using this. But apart from that, I'll see you soon.